Last video. Here we go. So again, we've made some progress towards answering this question, but we really haven't like busted out and came up with an answer, like maybe graph the results or done a whole huge simulation on it to figure out sort of what's going on. But the intent of this video is to sort of connect the dots and put it all together. Remember what we have as far as the things that we've developed so far. We've had this die object, so I'm going to hit Shift Enter on all these guys. So we've created this die object. We've created the 20. We've created this strategy that tells you whether you won or not for a particular role. We've created this simulation that gives you, if I put in 1,000 here, it'll give you the mean and whatever for 1,000. So now what I want to do is I want to create maybe all of the things that we're interested in. So I want to maybe have a start roll. Is that what we call it? Let me make sure. Start roll and num rolls. So I want to make sure that start roll is maybe 10, 11, 12, maybe through 19. It obviously can't be to 20, so we won't worry about that one. And then we will just create, I don't know, maybe 5 rolls or whatever, and then we'll run through all of those combinations. So that's the idea of this video, and then I'll graph it. So that's what I want to do. So start roll is equal to, let's do this comprehension I for I in range. We're going to go from 10 to 19, so this got to be 20. And then total rolls. We don't want this to run too long, so I'm going to say I. So again, you have to tell it how many, what's the maximum of rolls. I want it to go for I in range. Obviously, you don't care about 0 rows because you'll never beat it. So 1 through maybe 5. We'll just start there. And then curves is what I'm going to call this, the variable that's going to capture everything, right? So we're going to go and we're going to get a point for each one of these combinations. The point 10 with 1 roll, point 10 with 2 rolls, point 10 with 3 rolls, point 11 with 1 roll. So I'm going to do a for loop that goes through each one of these, and I'm going to do a J, so a nested for loop that goes through each one of these, and then we're going to put that into our simulation and figure out, and then that result.mean will be the answer for that particular combination. In other words, that'll be the average number of times that you actually win. And then I'm going to record that in this thing called curves. Again, I don't know why I named it curve, because it's going to produce a curve. I guess that's why. So np.zeros. Remember, every time we're trying to capture something like this, we usually do an np zeros, and it's going to be a matrix. I'm going to let the number of rows be the total rolls, right? So that's the I from 1 to 1 to 5 for that one. So it should be 5, and then so it'll be length, and then I want the length of the start roll. So start. Okay, and then we should have, all right, enter. So those are all of the variables that I need, and we could print them. I don't know, just make sure you guys see what these look like. So print start roll, just in case you can't imagine what these things look like. Print total rolls, and then print curve. Okay. So again, 10 through 19, which is what we want it to be, 1 through 5 being the number of rolls that we're going to stick in, and then this thing, this matrix, is capturing. So for roll one, I'll have the point 10 to beat will be right there. That'll be the average time that maybe, I don't know, 1,000, 10,000, however many we put in there. That's the percentage time that it beat that. And then we'll go to the next one. That'll be the point 11 with 1 roll, 12 with 1 roll, and so on and so forth. And then we'll come down, and with 2 rolls, we'll go back to 10, 11, 12. And so right now it's just a bunch of zeros, but I want to use this simulation thing right here and the result.mean. In other words, I can just average it in order to start filling in these numbers. And then we're going to simply just graph those numbers. So for S in start roll, right, I'm going to go through each one of those. For R in total rolls, I said I was going to do I and J, but I'm just going to grab them out. Result is equal to simulation, Relation. We'll put 10,000 in. We'll make it hopefully a little bit better. We'll pass in the die 20 and S comma R. Let me make sure that lines up. S being the start roll, and S goes with start roll, and R being the number of rolls, or is in total rolls. Okay, so that looks like that we've created what we're looking for. So right now, result would be what? It would be a vector of numbers, right? Because if you printed out result here, you would get a huge vector of 10,000, as a matter of fact, and then it had a bunch of zeros and ones. I can't record that in that particular spot. I need this probability, right? So, or not necessarily probability, but the number of times that actually occurred. So I'm going to let curves and then R minus 1. So think about why I subtracted 1 from here. In other words, that I want in the 0, this guy's 1, but I want it in the 0 spot, right? So I got to subtract. So whatever R is, subtract 1 from it, and then so that'll be on the 1 row. So again, Python, right? So Python is a zero index language, and so because of that, I want to subtract 1 in order to get this to be the 0th, the first. The 0, the 1, the 2, the 3, the 4, right? So because this would be row 0, that would be row 1, row 2, row 3, row 4. Okay. I don't know if I over-explained that or not. And then the column, I got to get this to go back to 0. So the column's got to be whatever S is minus what? Think about that for a second. And if I want this to be a 0, I got to subtract 10. So let's subtract those 10 from it. And then we're going to set that equal to result dot mean. Obviously, we can't put a big old giant matrix inside here, and then we're done basically. I think then we can print curves. So let's just print curves after that. Print curves. Shift enter. Oh, it's going to take a second or two. Why is it taking a second or two? Because you're running this thing 10,000 times for each one of these combinations, right? So for one, what was that? 5 times 9, so 45 times, and the 45 times 10,000. So it's going to take a few seconds to do. Again, numerical stuff takes that. It does that. So it shouldn't take that long to do, but you can kind of see what happens. So for row 1, remember that's well, row 0 if you want to think of it in Python terms, but it looks like 50% of the time we beat 10, 45% of the time we beat 11, almost 40% of the time that we beat 12, and so on and so forth. That's for one roll. For 2 rolls, right? So this is the row that we beat, right? So that we would for 2 rolls, it would see 10, 11, 12, 13, 14. So 14 is the number that basically prevents you from using 2 rolls. And then 3 rolls, you can kind of see where that cutoff is. Now, I'm not particularly satisfied with the way that looks like, so I'm going to use the reason why we brought in Matplotlib is I want to just make a graph. So anytime you're going to present results to someone, try to put it in a graph. I mean, a table's fine. I mean, if you can label it and there's not too many numbers, but this just feels like maybe 1 or 2 too many numbers, and so I want to just I'm going to use ggplot just because I like the way that one looks. Pot.figure. Let's see, we'll make it kind of big. So fig size, oops, size equals 12, 8. 4i, come on, man, in range, length of total rolls, right? Again, total rolls is 1, 2, 3, 4, 5, right? So we printed that sucker out. What do I want to do each time is I want to then plot with this. I want a plt.plot start roll, comma, curves, and then ith one, right? Because the ith curve, so that's the start roll is the 10, 11, 12. So on 10, on the number 10, I want to, oh, yeah, that's it. So for each one of these, right? So the 10 matches up with that 0.505. The 11 matches up with that 0.4533. The 12 matches up, and so I want to plot that being the x and this being the y for that for that one. And then I'm gonna come back and I'm gonna do it again. I want this to be the x and this to be the y. And then I want this, and so on and so forth, right? So I want basically 1, 2, 3, 4. I want 5 curves that are in this thing that basically tell me what happens when I'm using 1 roll, 2 rolls, 3 rolls, and so on and so forth. Okay, so that's what I feel like should happen. Oh yeah, so if I want to have this to be a point and then a line, we got to say O and then a minus. So that will give us a point, and then it will connect the dots with the line. Then plt.xticks. I had to look this one up. I'm gonna let it be start roll. Instead of 0, 1, 2, 3, whatever, I want it to be whatever the start roll is. Let's see what happens. Oh, good. Okay. So you can see that oh, well, we can label it. If you guys want to label it, let's see, plt.legend. So plt.legend, and let's give, let's see, 1 roll, comma, and I'm not sure. I think maybe you got to put it in like this. Here, let's try it and find out. 2 rolls, 3 rolls, 4. Oops, put it in. It definitely has to be a string. 4 rolls, and like that. I think maybe we've got to put it in as a list, possibly. Let's find out what happens if we do that. Oh, look at that. All right, good. So we put it in as a list, and you get, if you only had 1 roll and the point was 10, then you expect to be around 50%. If you're 11, and now if I want to draw a better picture, what I'd want to do is maybe put in a 0.5 here and have it go all the way across, so you can very quickly go, okay, 3 rolls, it gets me to there. So let's do that. Let's put in let's see, this should be plt.plot, and then what do we want to have happen here? I want to do np, I want to do start roll again as my x's, and then I want to do np.zeros with the length of start roll, just in case we change start roll, comma black. I want that to be black. Maybe I could put color equals. Find out what happens. I put it down there. Why did I put it at 0? Oh, because I just did a bunch of zeros. I'm a knucklehead. Let's do this. Ones. I think it should be ones. So if I did ones, it would put it at 1, but I don't want it to be ones. I want it to be 0.5 times ones. All right, so there you go. There's your black line that basically tells you that that a 50% chance for 1 roll, and that makes a lot of sense. And then you would do to 13, maybe 14. You'd have to maybe do a little bit more experimentation there. If the start roll is 15, then 3 rolls is definitely what you would need, and so on and so forth. And we could definitely come up and see how many rolls we would need for 19. Obviously, 5's not big enough, and you can kind of see how slowly it inches up. Again, that's the real question. Is there a number that they can give me in order to try to beat 19? In other words, the only answer you're going to get is 20. There is one. You could definitely figure it out if you just put a couple brain cells to it. Okay, so that's all I got this lesson. Hopefully you guys got something out of this, and I'll see you next time.